Okay, so in this video we are going to look at the central limit theorem in inferential stats. So we apply this when we have sample size greater than or equal to 30 for normally distributed data. Our formula for the z-score is in our log tables. You don't need to memorize it. The standard approach that we would have used before this was still in your log table. Z is equal to x minus your mean over the standard deviation. You'll see here in this formula there's no mention of n, so we didn't have a sample size. So central limit theorem applies when there's a sample size. The conditions for it: your sample size has to be greater than or equal to 30. The only time that we're allowed to apply it if it's less than 30 is when the data is normally distributed. So that's an important condition. The mean, as always, is mu. Your standard deviation or standard error is sigma over root n, and you combine that to give you the formula. Okay, we'll have a look at a question. So simple random sample. So we have a sample of size 35, that's my n. They tell me it's normally distributed, so I know now I can use empirical rule, z-scores, normal distribution, those kind of things. So we have a mean of 9, standard deviation of 2. In the question itself, they want the probability that the sample mean is greater than 10. Okay, so I've seen a sample size, I know central limit theorem, so I'm writing out my formula. They told us that the mean was 9, standard deviation of 2, a sample size of 35, and then they are looking for the probability that it's greater than 10. So what's happening here is they want the probability that x is greater than 10, and we're going to convert that x value to a z-score. So we can then apply our log tables, standard normal distribution. So we sub into our formula, z is going to equal 10 minus 9 over divided by 2 over root 35. All of this into your calculator. There's no need to simplify in between. Set up your fraction, 10 minus 9 divided by 2 all over root 35, quite a long decimal, 2.95, 8039. 892. Now, I'm not going to go to the log tables and find this exact decimal, so we'll round. So we get z is equal to 2.58, goes up to 6. Okay, so now we're going to log tables, 2.96, so I'll look for 2.9 first. My 0.6, we get 0.9985. So they want, here we have the probability that z is greater than 2.96. We know from the earlier video we don't carry out greater than, it'll be 1 minus the probability that z is less than 2.96. Our z-score for 2.96 from our log tables, we got 0.9985. Into our calculator, z, or 1 minus 0.9985, will give you back quite a small number, 0015. Okay, so there's our answer. That's us done. So it's 0.0015 or 0.15%. And there's an example of the central limit theorem. So the key here for us is once we see a mention of sample size, we know we're dealing with central limit theorem. Obviously as well, the data has to be normally distributed. Your formula is in your log tables, nothing to memorize. And then we just start off to find a z-score and then log tables as usual. And pretty much that's the question. So that's us done.